Hello everyone. This video we are going to cover section 10.1, solving systems by substitution and elimination. We have one example in this section. Solve this system of linear equations in three variables. The three variables are x, y, and z. They are linear equations because if you see those variables x, y, and z, the exponents on the shoulder of the variables are all 1. If you see the variable shows up, the exponent of the variable is 1. That make the equation linear equation. We have three variables, so this is a system of linear equations in three variables. I'm going to label the three equations as 1, 2, and 3. We are solving this system by algebraic method. Algebraic method includes substitution method and addition method. In algebra 1, algebra 2, we call the method addition method. Actually, it's the same with the elimination method in this book. So let's see how do we solve this system. We are looking for the values for x, y, and z, such that the values satisfy all the three equations. So if the system has a solution, then the solution would be in the form of an ordered triple. X, y, z. Let's see how do we solve that. For either substitution method or addition method, the key point of applying those methods is to try to eliminate one variable. Three variables too much. So if we could get rid of one variable, then we would reduce the difficulty of the system, of solving the system. So when I look at the three equations, I notice in equation 1 and equation 3, variable z has opposite coefficients. In equation 1, the coefficient of z is a -1. In equation 3, the coefficient of z is a +1. So if we add equation 1 and 3 together, let's see what would we have. We are adding equation 1 and equation 3. Take the sum of the corresponding terms. X plus 6x, that gives us 7x. Y plus -3y, that gives us -2y. Negative z plus positive z cancel out. On the right hand side, 1 plus 20, we have 21. I'm going to label this equation number 4. In equation 4, there are only two variables, x and y. Z is eliminated. Let me double check. 7x minus 2y. Okay, very good. So in equation 4, we have two variables. If we could have another equation only containing variables x and y, then we would have a system of linear equations in two variables. How do we reach that goal? How do we get another equation only contains x and y? So this is what are we gonna do? Equation 2. In equation 2, variable z has coefficient -5. If we multiply equation 3 by 5, +5, then we would have a different equation. Let's see what is the equation. If we multiply equation 3 by 5, 6x times 5, 30x. Negative 3y times 5, negative 15y. Z times 5, 5z, equals 20 times 5, 100. And in equation 2, I'm going to copy equation 2 right below this equation. That is 3x minus 4y minus 5z equals negative 1. Look at those two equations. If I add them up, we can label this number 5 and this number 6. And if we could add number 5 and number 6 together, let's see what's the sum equation, what's the addition equation. 30x plus 3x, 33x. Negative 15y minus 4y. Combine their coefficients. That gives us negative 19y. 5z, negative 5z, they cancel out. Equals right hand side 100 minus 1, 99. We are going to label this equation number 7. Okay, so let's see. Number 4 only contain x and y. Number 7 only contain x and y. And we are going to put those two equations together. Let me double check. 3x minus 4y minus 5z equals 91. This one is multiplied by 5, 30, 15, 100, 99. Okay, so we're going to put those equations together. 4 and 7. 7x minus 2y equals 21. And 33x minus 4y. No, minus 19y. 33x minus 19y equals 99. So equation 4 and 7. This system only contains two variables, x and y. So we could either apply substitution method or addition method to solve this system for x and y. So this is what are we going to do. Since variable y has simpler coefficients, 2 and 19, actually negative 2 and negative 19, they are simpler than 7 and 33. So I'm going to multiply equation 4 by 19. Let's see what we have. What is 19 times 7? 133 x minus 19 times 2, 38y equals 21 times 19. Let's see what is 19 times 21. 399. And equation 7, we're going to multiply by negative 2. Equation 7, each single term multiplied by negative 2. 33 times negative 2, negative 66x. Negative 19 times negative 2, positive 38y. 99 times negative 2, we would have a negative number. 198. And then we add them up. 133 minus 66. 67 x. And the negative 38y and the positive 38y, they cancel out when we add them up. And on the right hand side, 399 minus 198 gives us 201. Divide both sides by 67. We would have x equals 3. Yeah, I'm using a different method from the method I applied in the notes. Then you can have both methods. In the notes, I think I used the substitution method. Here, I applied the addition method. So of course, we are not done yet. We are looking for the values for x, y, and z, all the three variables. Now we only have the value for x. How do we find the value for y though? I would plug x equals 3 into equation 4. You can try number 7, but the number 4, equation 4, obviously is simpler. It has simpler coefficients. So that's the reason I choose number 4. Equation 4, 7x minus 2y equals 21. Let's plug in x equals 3. 7 times 3, 21. Subtract 21 from both sides. It cancels out. We have negative 2y equals 0. Divide both sides by negative 2. We have a y equals 0. So far we have the values for x, which is 3, for y, which is 0. And one more step. We need to find the value for z. Let me copy equation 1. We're going to plug in the values and for x and y into equation 1. Plug x equals 3, y equals 0 into equation 1. Let me copy equation 1. Equation 1 is x plus y minus z equals 1. The reason I choose equation 1 is because the coefficients in equation 1 is simpler. So now we put 3 in the place of x, put a 0 in the place of y. We have an equation only contain one unknown, which is z. So we have 3 minus z equals 1. If we move 3 over, 1 minus 3, that gives us negative z equals negative 2. 1 minus 3 equals negative 2. Divide both sides by negative 1. We have a z equals positive 2. So now we finish. We can make a conclusion. Thus, the solution of the original system is an ordered triple. Value for x is 3. Value for y is 0. Value for z is 2. This ordered triple is a solution, or the only solution of the original system. Okay? Yeah, I hope this is clear enough. You can repeat the video and make sense of it. In the next video, section 10.2, we are going to learn a different method. A different method is called a Gaussian elimination method. We are using matrix to solve a system.